In a revealing announcement that could change our position in the cosmos, NASA has reported the detection of the first extraterrestrial signals coming from the direction of Proxima B, the closest known exoplanet to Earth, located just over 4 light-years away in the habitable zone of its star Proxima Centauri. This discovery has generated a wave of excitement and curiosity worldwide. Could this be the moment when humanity discovers that it is not alone in the universe? The road to this momentous discovery began with meticulous observation by NASA's powerful telescopes, which have been monitoring distant stars and planets for signs of life. Proxima B has always been a leading candidate in the search for extraterrestrial intelligence because of its Earth-like characteristics and its proximity to our own solar system. The signal detected is distinctive and unlike anything astronomers have ever observed before, marking a possible turning point in human history. The implications of such a discovery are profound. First, it confirms the long-standing scientific hypothesis that life could exist on other planets under Earth-like conditions. Second, and perhaps more intriguing, it raises the question of the nature of the civilizations that might reside there. Would they be mere microorganisms or advanced beings possibly capable of interstellar communication and travel? This signal from Proxima B is not simply a random noise or a natural cosmic phenomenon. It carries a structured repetition that suggests an intelligent origin. NASA scientists, along with international teams, are now tasked with deciphering this message, trying to understand its content and the intentions behind it. The global scientific community is abuzz with theories and speculations about the possible content of this message, an eager greeting, a warning, or something completely unimaginable. News of this discovery has gone beyond the confines of the scientific community, sparking debates on social media, in government rooms, and around dinner tables worldwide. People are looking up at the stars with renewed wonder, pondering beings who might be doing the same thing on a distant world. How similar or different might their world be to ours? What would their society be like in terms of technology and culture? These possibilities seem as vast as the universe itself. In addition, this detection opens up a number of ethical and existential questions. How should humanity respond if the signals really come from intelligent beings trying to communicate? What protocol should we establish for interstellar diplomacy? And most importantly, how would such a discovery change our understanding of religion, life, and our very identity as human beings? While excitement is growing, there is also palpable wariness. Scientists at NASA and other space agencies are working diligently to validate these findings, ensuring that the signal is not a false positive or a misinterpretation. We are on the brink of what could be the most significant discovery in human history, so the next steps must be taken with precision and responsibility. The world waits expectantly for more detailed analysis. The detection of alien signals from Proxima B not only propels our scientific efforts into a new era, but also unites us with a collective curiosity and hope. We could finally be on the brink of answering one of the oldest and most profound questions. Are we alone in the universe? In April 2019, a radio signal was detected coming from outer space, specifically from the Proxima Centauri region, for 0.37 light-years away from us. Although it may seem a considerable distance, it is the closest star to the Sun, being 3 times farther away than the third brightest star in our sky. The signal comes from a triple star system composed of the binary pair of Alpha Centauri A and B and Alpha Centauri C, also known as Proxima Centauri. Alpha Centauri A and B, the two stellar companions, are relatively close to each other and are quite similar to the Sun. Alpha Centauri A shines with a yellow light and is 1.5 times brighter than the Sun, while Alpha Centauri B is half as bright with an orange hue. Alpha Centauri A is slightly larger than our Sun, and Alpha Centauri B is also smaller, so our Sun fits exactly between them in size. But where did the signal between these two stars come from? The groundbreaking Breakthrough Listen project, dedicated to searching for extraterrestrial communication in the universe, has named the Signal Breakthrough Listen Candidate 1, BLC-1. The project, which has approximately $100 million in funding, has used thousands of hours of observation with state-of-the-art telescopes around the world. The signal was detected by the Parkes Radio Telescope in New South Wales, Australia. This telescope was observing the region of Proxima Centauri, the closest star to our Sun. This signal almost went unnoticed among the vast volumes of data collected over thousands of hours, but the scientists managed to identify it like a needle in a haystack. For the signal to be considered relevant, it must have two definite characteristics. First, it must be limited to a small frequency range, since such radio signals are not created by natural mechanisms in space. Second, the frequency must fluctuate according to the relative motion of the exoplanet with respect to Earth. The scientists had to analyze nearly 4 million individual signals captured by the telescope in Australia. After an exhaustive process of filtering and eliminating unnecessary signals, they found 5,000 distinct signals, among which one stood out. A signal that could not be explained after cross-checking with contemporary radio transmitters on Earth. This unique signal, with a narrow-band technological signature, only appeared when the telescope was pointed towards Proxima Centauri, and was observed over a 30-hour period. After in-depth analysis, it was determined to be Proxima B, an exoplanet discovered by astronomers in 2016 using the radial velocity method, which detects variations in a star's position caused by the gravitational pull of orbiting planets. The star will describe a small circle. Extremely sensitive spectrographs are used by researchers to follow the light from a star. The spectrum of starlight shifts slightly towards blue as it approaches a planet, and towards red as it moves away from it. When these shifts occur repeatedly over days, months, or years, it is accepted that the variation in light is caused by the gravitational pull of an orbiting planet. On closer examination, Proxima B turns out to be very similar to Earth, with a radius 1.1 times that of Earth and a mass 1.3 times that of Earth, indicating that it is a rocky world with an equivalent density. However, there are significant differences. The first is the location of the two planets in their respective solar systems. Proxima B is much closer to its parent star at only 0.05 astronomical units, while Mercury is at a distance of 0.39 astronomical units from the Sun. This proximity would make Proxima B an extremely hot planet, but because Proxima Centauri is a dim red dwarf, the planet receives only 60% of the energy that the Earth receives from the Sun, placing it in the habitable zone where life could exist. There are countless unknown planets scattered throughout our universe. So far, we have discovered an impressive 4,935 exoplanets, and have recently added 65 new planets to our tally, bringing the total to 5,000 planets. This latest group of 65 exoplanets was added to NASA's Exoplanet Archive on March 21st of this year, marking a milestone in planetary exploration. The James Webb Space Telescope, JWST, is the most advanced telescope ever built, being 100 times more powerful than its predecessor. With its help, we will be able to unlock the secrets of this vast expanse of the universe. In the past, we have discovered a wide variety of planets, from small rocky worlds to gas giants larger than Jupiter, as well as extremely hot planets and habitable ones. Among these discoveries, a few planets stand out in particular. Kepler 1649c is one of those planets, whose characteristics are very similar to Earth. In fact, it is the most habitable planet we have found so far and could harbor life. So far, we have identified 55 Earth-like planets, but we have not yet been able to study all of them in detail. With the rapid advancement of our technology, especially thanks to the James Webb Telescope, who knows what more we will be able to achieve in the future? Wouldn't it be amazing to find a planet capable of supporting life? One of the main goals of the James Webb Space Telescope, during its first year of science missions is to find and study extraterrestrial worlds beyond our own solar system, focusing on how they form and the possibility that they can contain water and biological life. Webb's research on star and planet formation allows us to link studies of mature exoplanets to their birth conditions, as well as link our own solar system to their origins. Webb's infrared capabilities are ideal for revealing how stars and planets form for three peculiar reasons. Infrared light penetrates dust well, detects the thermal signatures of young stars and planets, and indicates the presence of key chemical components such as water and organic compounds. Mid-infrared light can pass through clouds that are 20 times denser than visible light, which is especially important when observing newborn stars that are hidden within their natal clouds. These infrared capabilities are crucial because they allow us to observe and capture the early stages of star formation when gas and dust are still contracting to give birth to young stars. But there is much more to the natal clouds of stars than that. Both young stars and giant planets begin as huge swollen structures that gradually contract over time. As newborn stars get hotter as they age, giant planets cool, but both emit more light in the infrared spectrum than at visible wavelengths, which means that the Webb telescope will be excellent for finding new stars and planets and helping to understand the physics of their formation. Webb's MIRI instrument will also search for hot molecular gas near numerous young stars, which could indicate the formation of potentially habitable rocky planets. Not surprisingly, much of the James Webb Space Telescope's early science work will focus on determining how planetary systems build molecules that may be crucial to the emergence of life.